OCR, Maths and Stats, Integration Techniques for C3 and C4. In this video we'll have a look at integrating linear functions raised to the power of -1. And the result is getting logs. Integrating 1 over some linear function of x. So looking at the formula here, we get ln ax plus b, the linear function inside the brackets, so the 5x minus 3, over a, which is the coefficient of x. The coefficient of x is 5, plus c. Or we can write this as 1/5 ln 5x minus 3 plus c. An alternative way of writing this would be to write 5x minus 3 to the power of -1. So now instead of looking at this form, we're looking at this form, a linear function raised to the power of -1. These are exactly the same, so the answer to this is the same as this. Integrating a constant over some linear function of x. So we're looking at this form here. So we have ln 1 minus 4x divided by the coefficient of x, and the coefficient of x is -4, but we're multiplying by 3 here, so that 3 goes here, plus c. So we've got -3 over 4 ln 1 minus 4x plus c. Integrating 5 plus 4x to the power of -1. So we have ln 5 plus 4x, and we're dividing by the coefficient of x, which is 4, plus c. Or we can write it as a quarter, ln 5 plus 4x plus c. When we have limits of integration, you have to modify the formula slightly, so remove the brackets and put in the modulus signs, like this. This will ensure that we are never working out the log of a negative number, and then removing the constant c because we have limits of integration, so our formula becomes this. So if you have limits of integration, make sure you're using the modulus notation here and not brackets, and there's no constant of integration either, as expected. Integrating 1 over 1 minus 3x. So we have ln, using the modulus notation this time, so 1 minus 3x. So that's the numerator here, this part of the formula. And we're going to divide by the coefficient of x. So dividing by the coefficient of x, which is -3, square brackets, and the limits. So substituting the limits in, and as you can see from here, we've got ln, and then this part here would be negative, so 1 minus 9 to give you -8, but because we have the modulus function here, that's no longer negative, so it's not a problem. And then simplifying, if I take the minus a third out from both of these, that leaves ln 8 minus ln 2, and then using the laws of logs, that gives minus 1/3 ln 4, and this is a negative number. Now, the reason we have limits here and we're integrating, it's to work out the area between the curve and the x-axis, and an area cannot be negative, so the final answer should be 1/3 ln 4. And if we have a look at the sketch of the curve y equals 1 over 1 minus 3x, this is the sketch, and from here we can see from x equals 1 to x equals 3, the curve is below the x-axis, hence that's the reason why we've got a negative value for the final answer here. But we know that area cannot be negative, so when you write down the final answer, change the sign from a minus to a plus. Make sure it's a positive value.